Hello and welcome. It is New Year's Eve here right now, and hopefully still New Year's Eve by the time I post this video, but I don't know how long that'll take me. I'm traveling, so my lighting situation is a bit questionable. You might just see the shadow of my face with a really bright light in the background, but whatever. I wanted to get this done before New Year's because I wanted to close out the year, but also because I have a fun project coming up for the month of January that I want to have a clean start for. Which I will tell you a little bit about before I dive into today's case. So in after the XL World Championships happened in Las Vegas earlier this month, and was featured in the Wall Street Journal and talked about in the media a lot and blah blah blah. I've had lots of people. I mean, I think lots of people in general have found out about it, become more interested in it, and I've had lots of people asking me, hey, how can I learn this stuff? How can I get good? Um, and so I got to thinking, hey, before the first round of the new season kicks off at the end of January, maybe I should put out some more kind of introductory basic stuff. And I got talking to Giles Mail from the Full Stack Modeler team about it, and basically what we've dreamed up is that we are going to jointly put together a sort of video training course over the course of the month of January, aiming to take someone who is kind of generally familiar with Excel but has never done an Excel World Cup style, like an esports style case before, and give them all the tools they would need to at least kind of get some points on the board, tackle the first few levels of a case within the time. And then depending on how it goes and the level of interest, that, like I said, we're aiming to have that in position for the first esports battle of the year, and then we may continue with sort of building into some more advanced stuff after that, but we'll see how it goes. Anyway, so that's what's coming up in January, but I could not close the year out without having a go at the finals case from the XL World Championships. That is what I'm going to do today. Now, this one is a large and complicated case, and so I'm going to kind of walk you through it first, because that way, if you've already read this or attempted it yourself, then you can skip that bit and just go and look at the solve. But obviously that means that if I then end up solving it in half an hour or whatever, which hopefully I will, that's certainly not comparable to somebody trying to read and solve in the same time. There's a lot of nuance to this that took some time to wrap my head around. So there are a lot of things that were very challenging about this case on the night that will not be challenging for me today because I've had some time to look at it. So the idea is the case is based on the game EVE Online, which is a multiplayer online game. I think thousands or more of people can kind of play in the same world at the same time. They told us the night before that the case was going to be about EVE Online, and I went online to try to think, okay, is there something I can find out about the game that'll kind of get me ready for this? And basically what I found is that it's vast and complicated and wasn't worth trying to get to grips with in one night because there's a lot there. But the bit that we're looking at today is basically we've got 7 different minerals, titanium, pyrite, mexilon, etc. We've got 5 different types of ship, each of which has a cost in minerals. So we're going to be interested in figuring out how much ships cost. These minerals are traded on a market in the game, and EVE Online has its own Excel add-in that lets you download kind of trading history for those. So we have the second tab is called Add-in Output, and that has the market history of prices for each of the 7 minerals spread out there. So we're going to be interested in the prices of all the minerals to create a ship at different points in time. That's basically the first half of the case. Then the second half of the case, there are different asteroids that we can mine to acquire these minerals. So there's 4 different types of asteroids we're given. 1 unit of asteroid ore has different amount of minerals in it and has a different volume in meters cubed. And so we have an asteroid field here where the color represents the type that matches up to the color on this summary here. And the number is the number of thousands of units, and so we're going to drive our barge that starts off in this R, drive it around, mine things, sell them, see how much money we can make, and so on. I guess the only other thing to mention is if you have looked at this question yourself, you may have found the instructions a little confusing. I certainly did on the night. In particular, this one here, that's sort of, well, that very definitely makes it seem like these numbers are the numbers of thousands of cubic meters of ore as opposed to the number of thousands of units of ore, which gives you completely different answers. So just if you try this question yourself, watch out for that. Basically, just ignore this note and do what the instructions up at the top say instead. Let's see. I think that's kind of all we need to discuss in advance. So I am gonna. Oh, I guess the last thing to say is just I'm gonna. Obviously, this is not kind of comparable to somebody doing it on the night, but in the spirit of this having been an elimination round, I'm gonna try and do it loosely in order of quickest marks to try to sort of build that up. But I'm also going to spend some time on setup so that things run smoothly later. So let's hit go without any further ado on my timer. So first thing I'm going to do is unmerge the list of ships and the list of asteroids. I'm going to name this, I'll just call it, I guess, SH list for ship list. I'm going to name this thing here SH min for ship minerals. I'm going to name this min list for minerals list, and I'll come back to the asteroids later because I don't need those just yet. So the first question asks how much the cost in ISK, which is the currency here, of the amount of tritanium you would need to make this kind of ship if the price is this. So we're just going to, sorry, not XLOOKUP because it's 2D, we're going to index on SH min, the ship minerals, and the row number is going to be, we're going to X match the ship type against the ship list. And the column number, well, we could say we're going to X match tritanium against that, or you can just look and say, okay, tritanium is the first column, so just column number 1. So that tells you this is how many units of tritanium you need to make that ship. Multiply that by the number of ISK per unit, that's the number of ISK you need to build a ship. Divide by 1000, that's the number of thousands of ISK you need to build a ship, and then for the answer we need to round to 1 decimal place. So we do that, that matches the 366 in the example. And hopefully when we put these in, I'm going to leave this column visible because this is not a live attempt, so these should all check out as we go. So for level 2, you now want to price all the materials going into a ship plus a 10% markup above the raw materials cost. So in other words, to build a Megathron, the table up above tells us how much of each of these 7 minerals we need. This tells us the price of each of those 7 minerals. You need to put that together to figure out the cost of the ship. So first thing we're going to do is XLOOKUP the ship Megathron in the ship list, in ship list, returning from ship minerals, and that gives us a vector of 7 minerals. We're going to multiply that by the vector of 7 prices. And that's prices in ISK, so this is the number of ISK we need for each mineral. We're going to sum up across those 7, divide by 1000 because we want our answer in thousands of ISK. We're going to multiply by 1.1 because of the markup, and then we're going to round that to 1 decimal place, and hopefully that will match our answer here, and it looks like it does. So then we'll copy that down, put it in here. Okay, so that's that. Let's just quickly do bonus 1 because it's kind of standalone. How many meters cubed of umber do you need to mine to have enough pyrite and isogen to produce a Megathron? So I found this one super intimidating at first because it's like you have to understand that umber is an asteroid and pyrite and isogen are, sorry, over here, pyrite and isogen are minerals, and the Megathron is up here and so on. But anyway, once you've understood that, the question is pretty simple, but one of the little nuances is these are the minerals per unit, but the question is about minerals per meter cubed. So the first thing I'm going to do, just because I know that I will use this later, is I'm going to create a table of the same thing. Just take the amount per unit divided by the number of meters cubed per unit, and that's going to give me the minerals per meter cubed. And so then my so I need the max of so the total amount of pyrite I need is 4 million, and I get 150 of that from each unit, and the total amount of isogen I need is 400,000, and I get 125 from each unit. So the larger of those two ratios, and then we just need to round it to a whole number, I think. So that checks out. So now, to do the next question, we're going to need to work with this add-in output. Now, there's a couple of things here that trip me up on the day. The first one is just that the range of dates provided here goes down much further than the range of these. So at some point I did a lookup on this, returning from this, and they're different sizes, and that threw me off. But the second thing is that because these are data types, which you may or may not be familiar with those, but the little kind of twist about those is this looks like it's the date 27th of November 2023, but if I put 2023 11/27 in a cell and then I X match this against that, it doesn't match, because even though this looks like a date, it's actually a data type that, you know, the name of it is a date, but there's a bunch of other stuff there as well. So that caused some confusion. But if you know how to deal with data types, you can just reference that cell and a dot, and one of the properties you can extract is the date. And then we'll just put that in date format, and we'll go down to the bottom of the 6-month range, and then you can quickly check that the minerals are in the same order. So we've got titanium, pyrite, mexilon, isogen, etc. And if I just put min list here, you can see that they're in the same order. So basically what we want, and you can also kind of check that they're all spaced out the same way. So we've got 3 columns between each one. So one way that I can pull all of these in is just to say index of this by sequence. We want 7 columns starting in 1 steps of 3, and that'll pull out all those prices there. So then I'm just going to give this a name. I'll call this DT for date, and I'll call this min PRC for mineral price. And then, as I mentioned, we're interested in getting ship prices as well, so it will be helpful to figure out the ship prices. So let's do that. We'll say 2 row of ship list. So given these mineral prices, how can I work out the price for ship? Well, the easiest way, I think, is to say transpose of sh min. Here we'll say transpose of ship list, just so we can label this. Sorry, no, that goes up here. And here we'll say transpose of mineral list. So in other words, to build a griffin, we need 24,000 titanium, 4,500 pyrite, etc. So then if I take this row vector and flip it, transpose it, multiply it by this column vector, that will give me the cost of each mineral that I need, and then I can multiply that across the whole thing. So what does that look like? I'm going to say this table here, lock times transpose of this here. That's going to give me my whole thing, and then I want to sum each column of that to get the cost of each ship. So we're going to say by col of that sum, and that gives me the cost of each ship. But we also need to include the 10% markup. So we'll say times 1.1 and copy that down. Okay, and then I'm going to call this SHPRC, ship price. Okay, so now here we have a fleet. A fleet has 5 different sectors, each with a different number of ships, and the type of ship is denoted by the color. So now this is, oh, actually I forgot to introduce this earlier, but let me kind of quickly tell you about it now. Do I have it here already? Yes, I do. So I had some macros and lambdas pre-written coming into the final. There's only one of them that I actually used in the final, which I've got here. I will make some more videos later to actually explain more of, you know, what things I brought in with me, and tell you a bit about those, because it felt weird to me to keep secrets in advance of the tournament, but I didn't want to spill my beans beforehand. But in any case, what this does is it fills every cell in a range with the color number, and this is like, I think this is you know, a number between 1 and 256 to the power of 3 that represents the RGB code or something, but it's how VBA stores the numbers. So it basically means that every time this appears, it's going to be this long number. We don't need to worry too much about what the number is, because we're just going to come up here, do the same thing here, and just name this shcol. And now we've got a lookup table that has the colors. So now we're going to come down here, we're going to say 2 row of shlist and 2 row of shcol. And now we're going to figure out, oh, sorry, that's because I put this in totally the wrong place. We are not on level 2, we are on level 3. So come down here, there we go. So now we're going to figure out how many, so we're going to sum these numbers where this number is equal to this number, and that'll tell us, for example, in this case, we have 22 stabbers and 32 drakes in this example. And we'll do the same thing, copy it down. And then we just need to price each of those ships. And we will do that by saying xlookup this date in DT, which is my list of dates returning from ship price, which is my list of ship prices, and that's in ISK. So that number of ISK times this number of ships gives me total number of ISK per ship. I don't know why it changed the format there, that's kind of annoying. Then we want to sum that up to get a total. And we want the answer in millions of ISK, so divide by 10 to the 6, and we want to round to 0 decimal places. So let's put a comma 0 and a round at the start. And that gives me 2306, which matches the example, so that means we're probably good. So I'll just paste that in here. Oops. Okay, so that's good, and then we also have the setup from that stuff to do 2 more of the bonus questions. And then everything else is to do with asteroids, and we'll go on and do that in a minute. So, what is the cheapest production cost of a drake in the month of October? So this is one where having this setup where we just have every date's cost for every ship is very helpful. So drake, I think, was the second last one. So here we come down to where are we? Here. So just the min of those, and sorry, we also need to give the answer in thousands and round to the nearest integer. So round to 0 decimal places. Okay, and then you buy 1 Megathron ship on any date in the given date range, and then sell it for a profit. What is the maximum profit you could have retrospectively received? Provide your answer rounded to the nearest million of ISK. Do not round interim calculations. You need to buy first, then sell. No short selling. So you could go and basically kind of build this out here. Say, you know, for each date, if you let's format these, make it vaguely easier to look at. You know, if you sold on this date, what's the cheapest you could have bought for, and hence what's the most profit you can make if you sell on this date, and work that down all the way down. But just for fun, let's do it all in one cell. So I'm going to say let all prices be this list of Megathron prices. Then we're going to say sell date can just be a sequence of rows of dt minus 1. So in other words, you can't sell on day 1 because then you'd have to buy before day 1, which is not possible. Then our profit, we're going to map sell date. So for each date, we want to calculate the maximum profit you could make by selling on that date. So lambda day. So for one day, we want the sale price, that's index all prices of day. So in other words, when we're doing day 1, that'll be here. When we're doing day 7, that'll be down here. Then we want to subtract the smallest of the prices you could have bought it for, and the price you could have bought it for is anything that comes further down than that day. So we're going to take all prices and drop the first day rows, take the minimum of that. That gives you that. Close the lambda, close the map. That's your profit, and then our output is just going to be the max of profit divided by 10 to the 6, and then rounded to the nearest whole number. And that checks out. Cool. All right, so now the second half is all about asteroids. So first things first, let's go and name stuff here and generally set the asteroids up as we did with the other things. So this is going to be ast list. This is going to be ast, I'll call it uvol for unit volume. This is going to be, I'll call this min per unit, and I'll call this min per M3, min per meter cubed. Okay, so that's that. Oh yeah, and then I also need colors. So let's do that here. So I'll just name that ast call. Okay, so then where do we start with asteroids? Okay, so we're always interested in the asteroids that are located on this map. I'm just going to rename this map for ease of reference. Put that over here. So these are the asteroids that are in the field. I'm going to copy that and get their colors. And we'll just Alt F8, run that macro, find and replace. Okay, and then I'm just going to shrink all of this down there, and then we're going to make a table of all of these things. So start with the address. We're going to have the units. We're going to have the type, and then we'll figure out other things after that. So first the address. So here I'm going to just use isNumber of this range. And you'll see that will give me false for the blanks, and it'll also give me false for this square here, which has the R in it. So that's going to be my kind of guiding thing. Then I'm going to say if isNumber that, then give me this and this, which is the address. So the letters and then the numbers. Otherwise blank, and that gives me all of those. Now I'm just going to change this to be otherwise NA, because then I can wrap this in a to-call and ignore errors. And so this gives me the list of the addresses of all the asteroids. Then I want to know the number of units in each one of these. So for that, I'm just going to replace the address with the cell contents, the unit number, press enter. Then I want the type, and that's going to be to-call of this area here, ignoring blanks. That's going to give me the type number, and then I'm going to look that up. I'm going to XLOOKUP that in AST_CALL, returning from AST list. Nope. What did I do? What did I do wrong? Oh, I bet I know what I did wrong. I bet I expanded. Yeah, AST list includes the two label cells, so they're not the same size. All right, so let's bring that back up. Enter, close. Okay, so now we've got the type. Then what else do we need to know? We need to know the volume, and we need to know the value. Now let's just check. I think for all of level 4 and on, we're interested in most recent market prices. Most recent market prices. Most recent market prices, and most. Actually, this one doesn't involve price. Fine. So yes, so for this one, we're always interested in the most recent market prices. So just basically this top row here, November 27th. So let's quickly work out. So we're interested in per unit. So we're just going to say take. We want the first row of min prices. Sorry, not min per meter cube, min per. Take row 1. So this is the latest price. Then here we just want, let's insert a little space here. Value per unit. And that's just going to be some product of this with this lock. That's it. Okay, and then I'll call this AstUval. Okay, so then the volume is going to be this times XLOOKUP this in AstList, returning from AstUval. And sorry, these are all thousands of units, so let's just bring that in right from the start. So then the volume is smaller for some, higher for some. That's fine. Then the value is going to be the number of units times XLOOKUP, the name in AstList, returning from AstUval. Okay, so that's the value, and I think that is the answer to the first question. So let's come on down here. So yes, the first question is, what is the total market value of minerals stored in each of these asteroids at the most recent market prices? Ignore waste. So we're going to XLOOKUP this in here, lock returning from Actually, I didn't even need to lock it today because I'm only doing one formula for all of them. Returning from here, lock, since I'm doing locks anyway, and then we want it in millions, so divide by 10 to the 6, and we want it rounded to 0 decimal places, so round. And now we see there's a couple of NAs here, and it says in case there's no asteroid in a cell, provide 0 as your answer. So let's just quickly check, but that should be what that is. I-14, yeah, so that is no asteroid, so we'll just say if not found 0, and that's that level. Okay, so now level 5. So on level 5, two things to factor in. One is you've now got mining skill. So by default, when you mine an asteroid, you only get 75% of the volume and hence of the value of the minerals, unless you have skill. So the default is 0 skill, and then each skill point adds 5 percentage points of material. So the maximum skill you can have is 5. If you have 5, you get 100% of the minerals out. If you have 0 skill, you get 75% out, and then it's 85, 90, sorry, 80, 85, 90, 95, and 100. So that's the first thing to factor in. And then the second thing to factor in is we've got this barge moving around to get them. So the barge has a maximum capacity of 27,500 cubic meters, so we can only mine as much as we can mine. So I'm going to need a data table for this, so I'm just going to my current preferred way to do data tables, or to do the setup for a data table, I should say, is to say, leave that where it is, and then over here we'll say xlookup, xlookup. This in here, just in there, returning from all of this stuff. Okay, and then if I change this to whatever 84, it'll update the values. So then if I just do all the calculations of this, then I can data table that really easily. So first I want my list of addresses, and that is just going to be 2col of this. Then I want all the other information that comes with the addresses from here. So my units, type, volume, and value. And for that, I'm just going to xlookup this in here, returning from here. And I will need to lock both of those. I don't know why it didn't snap me back when I hit F4 that time, but it usually does anyway. So fill that down. And let's just take our format over here as well. Okay. Alright, didn't want all of that, never mind. That's fine. So then we want the skill adjustment. That's going to be xlookup the type in here. Lock, returning from here. Lock. So that's the skill level, and then to turn that into a skill adjustment, that times 5 percentage points plus 75 percentage points. So that's that. So then I want the edge volume, because that's what's going to determine how I fill up my ship, and then the edge value, which is going to determine how much money I make. So the volume is just that times that. Let's copy this format over again. And the edge value is going to be this times this. So then we're going to be gradually filling up our barge. So let's just do that. We'll say barge. So it starts off at 27,500. Then we're just going to say max of that minus the adjusted volume and 0. And again with the number format. Okay, so in this case we don't actually fill the barge, but in other examples we do. This is a funny one actually. I realized after the fact that if you'd completely ignored the barge constraint capacity and just figured out the value of each of these with the skill adjustment, you actually get 19 of the 20 questions right, which was probably not completely intentional that you needed so little of the complexity to do it. But anyway, so then we'll have mined, and that's going to be just this, it's just that minus that, right? And I guess what I really want is the percent mined, which is going to be that over the adjusted volume. Sorry, sign's the wrong way around. So that is, we're 100% mined. And then my mined value is just going to be the sum of the percent mined times my skill adjusted value. And then I want that, I think, in millions, rounded to the nearest integer, yes. So we're going to round this over 10 to the 6 to 0 decimal places, and that gives me 567, which does match the example. So then let's data table it. And column input cell is going to be this guy right here. And we'll hit recalc, and hopefully that's good. Okay, then level 6 is a little bit like level 5. There's, again, two extra twists. One is, rather than having a default order for these, you're going to tackle them in order of profitability. That's the first thing. And then the second thing is that you're going to pay a cost for the distance you travel. Now, something interesting here. So, well, two things. One is you're interested in tackling them in the order of highest value per meter cubed. So ISK per meter cubed, we've already got the value and the volume, so that's a pretty easy calculation. I'm just going to round this to 0 decimal places, just so that, if there's a rounding error in calculating, this one versus this one, then these might sort as different values. I want them to sort as exactly the same value, because then there's a secondary sort, which is you do the most valuable mineral first, and then you do in descending size of the asteroid. So you might think, looking at this, well, you have different skill levels for each of these, so maybe you'd have to tackle them in a different order depending on your skill level. But actually, the skill adjustment basically hits both the volume and the value. In other words, you get less of the stuff, and hence you get less value, but the ratio stays the same regardless of your skill level. Like, whatever amount of it you get out, it still sells for the same dollars per unit. And so you always tackle them in the same order. So you don't have to think about sorting them dynamically. But then the other thing is, there's this instruction here that the barge selects the shortest possible route, but they can't travel through asteroids that are not mined yet. So it makes it seem like you're going to have to do some weird calculation of, I don't know, let's say if I need to get from here to here, but these two haven't been mined yet, then I would have to go out around them and do some like weird calculations. But it turns out that you don't need that at all. Once you figure out the order in which to tackle them, there is always a clear path of the minimum possible length from one to the next. So I'm not going to do that at all, but I will tell you that I've looked at it and I've compared notes with Andrew on this as well. He came to the same conclusion. So anyway, that is what it is. So hence, I'm just going to ignore that piece. So let's think about the order in which we need to tackle the addresses, and that's going to be sort by. So the order is going to be sort this by first by ISK per meter cubed -1 descending order, then by the number of units, and again descending order. So that's going to give us that. Let's call that address, and then basically going to import most of level 5 into here. And we'll carry this down. So you can see we always do Omber first, largest to smallest, then Kernite first, largest to smallest, then Veldspar, and so on. Then the skill adjustment, oh yeah, so sorry, here I'm going to do the same thing as before, just insert another copy of this, get rid of all of this. And then let's do XLOOKUP this in here, returning from here. And then we will bring all of this up there. Okay, so now my skill adjustment, I'm just going to need to change where I'm returning from. They're still in the same order, so I can just look up in here. And I need to change the size of the range that I'm looking for, because now got a longer list, and aside from that, that part still works. So my adjusted volume is good, my adjusted value is good. Just need to make it bigger. My barge, not marge, and percent mined. That all seems to be working. So then the question is, what again? Total profit. Oh yeah, sorry. So then we need to consider the travel cost. I guess the other thing, if you try this at home, it doesn't actually spell out whether your barge can move one unit, meaning up, down, left, right, or meaning diagonal as well. But to match the answers, you have to allow it to move diagonals. So it starts off in F10, and so we're interested in the diagonal distance between F10 and H9, which is between here and here. So in this case, we have to move 2 steps. So one diagonal to there and then one to there. The way you can think about this is draw a rectangle around these two, and it's the smaller of the number of rows minus 1, and the larger of the number of rows minus 1 and the number of columns minus 1. So you could do a bunch of stuff to split this out into component pieces, but a nice way to do it is just let A be indirect of this and colon and this. Then we just want max of rows of A and columns of A minus 1. So that's the distance, and then the dist cost in ISK millions. So you have to pay 1 million ISK per distance you travel, but you don't have to pay anything to get back at the end, and you only obviously pay to travel to the ones you mine. So if the percentage mined is greater than 0, then give me the distance, otherwise give me 0. And you total that up, and that's it. So then we're just interested in the sum of percent mined times adjusted value divided by 10 to the 6 minus the sum of the distance costs, which are already in millions, so no 10 to the 6 there. 1365 matches the example, and then we just need to round that to 0 decimal places. And then we need to make a table. And now level 6 also relates to, level 6 also relates to a bonus question, so let's just tackle that while we're at it as well. No, I should have done this one earlier. Compare the value of the 4 asteroid types in ISK per meter cubed of ore at November 1 market prices. So that's kind of basically the same as what we've already done. Let's XLOOKUP date 2023 11/1 in DT returning from min PRC. So that's the prices on that date. So let's say NOV1 prices. And we put that next to the minerals per meter cubed. So we say sum product of this with this, lock, copy down, and then I think we're just interested in the max of these. Yes, highest value in ISK per meter cubed, rounded to the nearest integer. So first we just take the max of these, and then we round to 0 decimal places, and that one's good. And now here, what is the total remaining unmined amount of asteroid ore in cubic meters across the games on level 6, including example 6? Now there's a little nuance here, which I think the answer provided here is actually wrong, but I'm going to show you 2 ways to calculate the answer. So first, we basically have 0 of all of these, we have 41% of this, and we have 100% of all of these. And we have the volume of them over here. So it should just be sum of 1 minus the percent mined, in other words, the percent not mined, times the volume in meters cubed. And then I think we're interested in the answer in thousands of meters cubed, so I'll just divide by 1,000. That, I think, is the correct way to think about it. But if you think about it, so the question says the total unmined volume, but if you think about it instead in terms of the adjusted volume, i.e. how much volume would you take back if you kept going out with your skill adjustment only getting some and there's a certain amount wasted, then that would give you a slightly different answer, which is, let's just copy this, put it here. Basically, if instead of pointing at volume, you point at adjusted volume, I think that's the one that you need. Sorry, that's adjusted value. Let's go back one to adjusted volume. That's the one you need to match the answer as far as I remember. So let's do these calculations, and hopefully we'll get level 6 and bonus 5, and then we're almost done. Level 7 is not too crazy. So first we'll take these, drop them in here, and that all checks out good. And then we're interested in equals round of sum of all of the, sorry, I'm mixing myself up. It was not in thousands, was it? Let's just quickly check. Total amount in cubic meters, sorry. So I should not have done thousands. Pardon a senior moment there. So then we refresh, and now we want round of sum of all of that to 0 decimal places. So this is what I think is the right answer. This is what I think will check out as the right answer. And it does. Okay, so finally, I think that just leaves level 7, right? Yes. Okay. So level 7 is just a totally new thing. So we have 50 new asteroids spawn. So again, same thing. The color says what kind of asteroid it is. The number says the number of thousands of units. So first thing we're going to do is just do the same trick as before to convert these colors into just call it asteroid color. So I'll run that macro again. Whoa, what the? No, did not want to open up OneDrive. What? Oh, sorry, because I got the function key pressed down. That's why it keeps springing up. Let's try that again. Run my color macro. There we go. And then same trick as before to convert this into. So I need 2 row of my ast list, and I need 2 row of my ast col, asteroid color. And then just like we did with the ships before, where we had the same setup, we're going to sum these numbers where these color types match this color type lock, and that's going to tell me how many units. And actually, sorry. Well, yeah, so that will tell me how many units, but then I'm also just going to apply the skill adjustment right here to figure out. So I'll just label this skill ag units, and then also these are thousands of units, so I'm going to multiply them by 1000, and then I'm going to multiply them by the skill adjustment, which is 75% plus 5% times your skill number over here. Okay, so that tells you how many skill adjusted units of each thing you get. The question here is there are 2 types of ship that only require the 4 minerals. So there are 3 minerals that are not found in any of these asteroids. But there are 2 types of ship that can be built just from the minerals found in asteroids. And so the question is, from all the minerals in the 50 different asteroids, you make as many thrashers as you can. And then with whatever is left over, you make as many griffins as you can. And so the kind of output answer is something like this, T268G1. So in other words, out of these 50 asteroids, we should be able to make 268 thrashers and then not be able to make any more, and then have enough left over to make 1 griffin and not be able to make any more. So let's come over here. So first of all, we want to convert this. If we have 38,000 units of Veldspar, what does that translate to in terms of the minerals? So let's do min list. And again, these last 3 don't exist in any of the asteroids. So I'm just going to say take from min list 4 columns. And then here I'm going to have min per unit. And again, I'm just going to take the first 4 columns of that. Then I'm going to have my ast list here, and I'm going to have my, well, just copy this formula. Okay, so then again, same trick as before. If I take this, transpose it, multiply it by each one of these, that will tell me how many units of titanium, pyrite, mexilon, and isogen I get from each type of asteroid. So that's just going to look like this. This lock times transpose of this. And then I just sum that up by column to get the totals for each mineral. Sorry, got to put in a function. So sum by column. So that tells me the total number of units of each mineral. And then I'm interested in how many units do I need to make a thrasher, and how many units do I need to make a griffin. So we're going to XLOOKUP this in SHList, returning from SHMin. And again, we'll just take the first 4 columns of that because that's all that's relevant. Okay, so then question is how many thrashers and how many griffins. So think about the thrashers. You want to say this divided by this lock, and you want the biggest whole number that's smaller than any of these. So in other words, you want int of min of all of these, and that in this case is 268, which is what we were looking for. And then you want to do basically the same thing for the griffin, except that your numerator is going to be what you start off with minus this times this lock, because that's what you've already used up on thrashers, and then this is just going to point to the next row for griffins, and then everything else stays the same. So then the output is just going to be T lock and 268 and G. Whoops, what the heck happened there? Oh, sorry. Ampersand. That lock and this. And then hopefully that all checks out. And I think that means we've got everything. Or somewhere here. Yes, there we go, 2000, which is the full score. Okay, so you can see that even with kind of knowing a lot of the intricacies in and out, this still took me 40 minutes to solve. So it's a pretty meaty case. I did a certain amount of chit-chatting. I could probably have kind of squeezed that down to half an hour if I really needed to. But you think about trying to solve this on the night with, you know, all of this to digest, and you have, you know, under 5 minutes to get points on the board. So you're effectively heavily discouraged from actually taking the time to get familiar with this. You can see how the scores ended up being, I think, all sub 1000. This was like, I think it's a lovely question now, looking at it and fully understanding the instructions and where to go. I thought it was a very rough question on the night, but that is what it is. Anyway, that's what I've got. Happy New Year. And like I said, I'll be back in January with